All right, everybody, here we go. We're going to start out with some Polygon properties. And a lot of what you see here is just some information you need to know about polygons in general. First of all, a polygon is what you guys probably just call shapes. Only thing about polygons is all sides need to be connected to another side and they have to be straight lines. So it's easier to understand a polygon by just doing some examples of what are not polygons. This bow tie is not a polygon because it's actually just two polygons put together. They're just two triangles. So by itself, it's not its own shape. This one is not a polygon because it's not closed. All sides need to be closed. And the last example, you are not allowed to have any curves in a polygon. So that would be a different type of shape. So those are examples of what things are not polygons. Everything else pretty much is a polygon. Concave polygons cave in. It would look like this if it was a straight line. This would just be a convex. There are no caving in, okay? All diagonals would be inside of a shape. Regular means all angles are congruent and all sides are congruent, but an irregular means that is anything other than a regular polygon. So remember, regular means all congruent sides and all congruent angles, such as an equilateral triangle shown or a square. And then names of sides. This is something you probably already know from back in the day. 3 sides is a triangle, 4 is a quadrilateral, 5 is a pentagon, and then after that, everything ends in gon. So 6 would be hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Anything above 10, I'm not going to make you memorize, so you can just say n-gon for n representing the number of sides. So if it had 15 sides, we would just call it a 15-gon. Alrighty? So those are the basics about polygons. What we're going to work on now is all the different formulas that go along with it. So we're going to spend a minute and just kind of talk about these things. So knowing the number of sides of any polygon is obviously as easy as just counting, unless it's just given to you in a word. Like pentagon, you would need to know that that has 5 sides. So we're going to spend a little time talking about this chart with this pentagon. So to help you, we're just going to draw a pentagon. Now, the number of triangles is always going to be the number of sides minus 2, because what you do is you pick one vertex to do this from, and you draw diagonals. And look how many triangles you have. You have 1, 2, 3 triangles. So that is the number of triangles. So if we're going to work with a pentagon, 5 minus 2 would be 3, which is exactly what we see here, 3 triangles. Again, you only draw diagonals from one vertex. How many diagonals can you draw? Well, if you look, we were only able to draw 2 diagonals. And the reason why, we can't draw a diagonal to this vertex because that's just following a side. We can't draw a diagonal to that vertex, again, because it's just following a side. And we can't draw a diagonal to the same vertex. So it's always going to be 3 less vertices you can draw diagonals to. So that's why the number of total diagonals drawn from one vertex is 2. Now, the total number of diagonals in this entire diagram, you can draw 2 from each vertex. So you can draw 2 from this vertex. You can draw 2 from this vertex. 2 from here, 2 from here. So technically you think it's 2, 2, 2, 2, and 2, so you would think there's 10. But really, there's only 5, because you have to divide that number in half, and here's why. If you draw, say, this diagonal from this top vertex, and then we went down to this vertex and we drew this diagonal, and then this one, they're going to overlap. So really, you divide it by overlapping sides, which would be 2. Okay? So let's get rid of this stuff here. Now we're going to talk about the sum of the interior angles of a polygon. So the formula is 180 times n minus 2. Now we already know that n minus 2 represents 180 times your number of triangles. And if we draw, we have 180 times, again, we have 3 triangles. So 180 times the number of sides, which is 5, minus 2 is 180 times 3 is 540 degrees. All right, that's how you do the SI formula. That's where it works. No matter what shape you're talking about, the exterior angle sum is always going to be 360 degrees, okay, no matter what. And I can show it to you with a couple of shapes. We know that here's a triangle, and let's call it equilateral where they're all 60, 60, 60, and 60. The exterior angle from each angle is going to be 120. This guy's going to be 120. This guy's going to be 120. So 120 plus 120 plus 120 is 360. If we look at a square, all the insides are 90. Draw your exterior angles. This guy's going to be 90, this guy's going to be 90, this guy's going to be 90, and this guy's going to be 90. So the exterior angles, 90, 90, 90, and 90, is still 360. So no matter what, the exterior angle sum is always going to be 360 degrees no matter what shape you're working with. So that's that. Now these are going to be for regular. Whoops. These guys are going to be for regular polygons, so each interior and each exterior. So EI, that represents each interior angle. So if we know that the sum of all 5 angles in this pentagon is 540, all you have to do is divide the sum by 5. So you just have to take the sum and divide it by the number of sides. So 540 divided by 5 is going to give you each angle is 108. And to find each exterior angle, we know the sum is always going to be 360, so we just have to divide 360 by, again, the number of sides, 5, and we find out that every interior angle is going to be 72 degrees. Okay? And we already said the number of diagonals from 1 is 2, and the total is 5. So that is how you use this chart. Now, there's another little thing. Interior angles and exterior angles will always add up to 180 degrees. That's another good thing to know. Next example, we're going to find x. Now, this is kind of like triangle problems where all triangle angles add up to 180 degrees. Well, in a hexagon, you have to first find SI. Now, we know that this has 6 sides. So the first thing we have to do is 180 times 6 sides minus 2. So that's 180 times 4, which is going to give us 720 degrees. So before you just add these up and set it equal to 180 or 360, you have to find out what they add up to. So then you're just going to add these all up. So you have 3x plus 7x plus 6x plus 5x plus 5x plus 4x is equal to 720. So then that would be 10, 20, 30. So 30x is equal to 720. So divide 720 by 30 and you're going to get x is equal to 24. So now that you know x is equal to 24, you are good to go for this problem. This next one, it lists exterior angles. So you know automatically that no matter what, exterior angles will always add up to 360. So you have 1x, 2x, 3x, 4x, and 5x. So that's going to be 5, 10, 15x is equal to 360 degrees. So you just have to divide 360 by 15, and you're going to end up again with x equals 24. That's just a coincidence. So last thing is just working backwards with some of these properties. So SE of a 100-gon. So it's got 100 sides, but it's not difficult because it's SE. SE is always equal to 360 no matter how many shapes. Okay? Un represents just one interior angle of a regular decagon. So remember, the first thing you have to do is find the sum of a decagon. So that would be 180 times 10 sides minus 2. So that would just be 180 times 8, which is going to be 1440. But that's just the sum. 1440 is the sum. We just want to know what the measure of one interior angle is. So we would have to divide by the 10 total angles in a decagon, and we get 144 degrees. So this is just using the formulas. Last three examples. You're working backwards now. So I am telling you that the sum is 1440. Now, we already know the answer is a decagon because we just got done with it, but this is how you do it algebraically. SI is 180 times the number of sides minus 2. And we know that's equal to 1440. So now this is just an algebra problem. So you're just going to do 180n minus 360 is equal to 1440. All we did was distribute the 180. Add 360 to both sides. 180n is equal to 1,800. Divide both sides by 180 and you get n is equal to 10 sides. Okay, so this is a decagon. Next example. It's telling you that each interior angle is equal to 360. Now you know EE is equal to 360 divided by the number of sides. And that's equal to 36. So 360 divided by what number gives you 36? Well, the shortcut way is just switch those guys. So you have 360 over 36 is equal to the number of sides. So n is equal to 10. Again, we have another decagon. The last one says EI is 90. Now, I can show you a very long way to do this. We know that the EI formula is 180 times n minus 2 all over n, and we know that that's equal to 90. Now, use a little bit of algebra, multiply both sides by n, and you have 180 n minus 360 is equal to 90 n, because those guys cancel and you just distribute that. And now all you have to do is add the 360 to the other side and subtract your 90n to the other side. And you're going to get 90n is equal to 360. Divide both sides by 90. And you're going to get n is equal to 4. Now I said that's the complicated way. So what's the easy way? Well, if you remember earlier, I told you EI plus EE is always going to add up to 180 degrees. Each interior is always supplementary to each exterior. So if each interior is 90, that means each exterior is equal to 90 as well, because they have to add up to 180. And then it's just as easy as saying 360 divided by 90, and that's going to be 4. So you're going to get the same answer, but just finding what's supplementary to the interior angle is a much faster way of doing it. Alrighty, so that's it for Polygon Properties. This is Longo, and I'm out. See you, bye.